Welcome to this Maths Made Easy video on the addition and double angle formulae. And to start with here, we're just going to give the expressions for the addition formulae. So we have three results here, and we're just going to denote each result as we go. So the first result we need to be aware of here is sine of A plus or minus B here. And for sine of A plus or minus B here, we simply obtain sine A times by cos B plus or minus sine B cos A here. And remember, these are just products. So this is sine B times cos A, and again sine A times cos B here at the front. So that's our first result that we need to be aware of. The next result that we need to be familiar with is cos of A plus or minus B. And this result is cos A times by cos B. Here now, just be slightly careful, it's not plus or minus, but minus or plus here. Okay, so we write it upside down essentially to what we had here. And this is sine A times by sine B there. Okay, and that gives us our second result. And finally, our final result here is tan of A plus or minus B. And this result is simply given by tan A plus or minus tan B. This is all over 1 minus or plus tan A times tan B there. Okay, and that gives us the three results that we need to be aware of for the addition formulae. There's one brief comment we need to make here, and that's regarding a bit of notation. So be very, very careful when you see this symbol here of minus plus. Okay, this isn't a mistake. We do use this symbol, so let's just quickly show how this symbol works. So if we just write our addition formula for cosine, this is cos of A plus or minus B here. And this is simply expressed again as cos A times cos B minus or plus sine A sine B. So how do we use this symbol here in relation to our plus or minus? Well, the way these symbols work here is that if we take the top symbol, so this plus here, when we're doing cos of A plus B, then we also take the top symbol here on this minus or plus. So what that essentially looks like here, is if we take the plus, this is cos of A plus B, and this is simply giving us cos A cos B minus then, because we took the top symbol here, we also take the top symbol, so this is minus sine A sine B. And alternatively, if we were to take the bottom symbol here, so we were doing cos of A minus B, then again we take the bottom symbol here of plus. Okay, so we would add sine A sine B to cos A cos B. So in full, that's going to look like cos A cos B plus sine A sine B there. So that's just a little comment there. We must be careful with the notation. And finally, we want to show how we can derive the results for our double angle formulae using our addition formulae. So what I'll do here first is give the result and make sure to take note of that result, and then I will show you how to derive that result using the addition formulae. Okay, so I'll do that for sine and cos, and tan will be left as an exercise. So to start with here, if we take the double angle formula for sine, so that gives us sine of 2A, which we can simply express as 2 sine A cos A. So how do we derive this result? Well, what we do here is we use our addition formula for sine. So using sine of A plus or minus B here. This is expressed as sine A cos B. So sine A cos B plus or minus sine B cos A. Okay, we're going to use this now with A plus A to obtain sine of 2A. So therefore sine of A plus A, that's going to give us sine of 2A. And all we need to do now is just simply replace here our b's with an a, because that's what we've done here. So it's gone from sine a plus or minus b to sine a plus a. So in that case, we obtain sine a cos a. And again, this is the top symbol here we're adding, sine a plus a. So we also take the top symbol here of a plus. And in that case, that's going to be sine a cos a. And in that case then, all we need to do is simply take a look at this result and see how it simplifies. We've got sine a times by cos a here, and again we've got another sine a times by cos a. And if we add them together, simply what we've got then is two lots of sine a cos a, which gives us our initial result here. Okay, so it's worth trying to remember these results, but if not, you can easily derive these results using the addition formulae. Let's also derive here cos of 2a, and cos of 2a can simply be given as the following. And this is cos squared a minus sine squared a. And how do we derive this result again? Well, it follows in a similar fashion to how we derived sine of 2a, in that we're going to use the addition formula for cos now. So this is cos a plus or minus b here. And writing that out in full then, that gives us cos a cos b. So cos a cos b. Remember the symbol changes here now, so it becomes minus or plus. And then in this case it's going to be sine a sine b. And all we do here now, again, is we want to add a and a together to obtain 2a. So this is going to be cos of a plus a then. Okay, so let's just write that out, sorry, over here. So that was sine of 2a. And again here, we're going to repeat this now. Again, replacing the b's here with this a. And as we've took a plus here, then we're going to take the minus again. Remember, the top symbols correspond, same for the bottom symbol. So this is going to be cos a times by cos a. And here now, we're going to minus sine a times by sine a. So sine a times by sine a. And all we need to do now is just simplify our result here. If we've got cos a times by cos a, then that will simply give us cos squared a, which is the first part of our double angle formula here for cos. And finally, sine a times sine a will give us sine squared a. So this is minus sine squared a. Okay, and that gives us our exact result here that we needed. Now it's worth pointing out that there is actually some variations we can use here, using one of the identities that we've already established. So using sine squared a plus cos squared a gives us 1. We can rearrange these to be in terms of sine squared a and to also be in terms of cos squared a, and we simply substitute those into here. So rearranging here, what do we obtain? Well, we obtain sine squared a is 1 minus cos squared a. So 1 minus cos squared a. And again, we can rearrange then here in terms of cos squared a. So cos squared a is also going to be 1 minus sine squared a. Okay, so in that case now, all we simply need to do is replace cos squared a with this expression here and replace sine squared a with this expression here. And doing so, we obtain these variations in this case. So substituting sine squared a in here, that gives us cos squared a minus this expression here, so that's minus 1 minus cos squared a. Okay, and if we evaluate that, that gives us cos squared a minus 1 plus cos squared a. And if we simplify that, we get 2 cos squared a minus 1. So there was a cos, an a there, sorry. Okay, and if we simplify that then, we've run out of room a little bit here. So what we'll do is we'll just clear this side over here first, just so we've got enough room. So I'll quickly clear this. Okay, so we're pretty much there now. So in that case, if we just finish off our our substitution here, sorry. So we obtain for cos 2a, but we can also express that as 2 cos squared a, 2 cos squared a minus 1. Okay, and then finally substituting cos squared a in here to our expression, then we obtain 1 minus sine squared a. So that's our cos squared a there. Substituting that in from here, and we also got another minus sine squared here. Okay, and this is again for cos 2a. And if we simplify this result here again, then we're also going to obtain 1 minus sine squared a minus another sine squared a. So therefore, cos of 2a is simply 1 minus 2 sine squared a there. Okay, so those are our 3 results. If we just highlight them with a different colour, these are our 3 results here. So we've got this, and finally the original one that we started with, and use that to derive the following 2. And finally then, we have one more double angle formula, and that's for tan of 2a. So I'm not going to show the derivation of that result. I will leave that as an exercise for you to attempt, but you would just follow it again using the same pattern that we did for sine and cos, but I will give the result that you should obtain here. So make sure to have a quick go at it now, pause this video, and then make sure you attempt that to see if you can obtain this result. So for tan of 2a here, so for tan of 2a, all we simply obtain here is 2 tan a over 1 minus tan squared a there. Okay, and that gives us our 3 formulas for the double angle formulae. And that concludes this Maths Made Easy video on the addition and double angle formulae.